Hello everyone and welcome to another episode of Nowhere Yudarris. Today we'll be uncovering physics' own work and energy. Alright, we'll be going through kinetic energy, potential energy, elastic potential energy, etc. etc. We'll be looking at even mechanical advantages. So let's start. So what is kinetic energy? Kinetic energy is the energy of motion, and what is the formula for it? It's K equal half times mass and then volume is to the power of 2. Realize that kinetic energy is related to speed, but if speed doubles, kinetic energy quadruples. That means that kinetic energy is directly proportional or 2 times directly proportional to speed. So it's half times mv squared. Remember that. Then we have potential energy. Potential energy is really simple. It's basically a stored energy that has the potential to do work. So for instance, grab a ball, grab any object. Each of the objects you just grabbed, it has potential energy to be or to exert kinetic energy, thermal energy, etc., etc. Then we have gravitational potential energy. So gravitational potential energy depends on the object's position with respect to zero potential energy. So basically, the gravitational potential energy formula is U equal mass times the gravitational constant or acceleration times height. So the gravitational constant is the acceleration due to gravity, which is 9.8 meters divided seconds squared. Let's have an example here. So a diver leaps, he's 80 kilograms, leaps from a 10-meter cliff into the sea. Alright, here goes the diver. So he got the mass, he got the height, and then the gravitational constant here, and then this is used to calculate the gravitational potential energy. Next you have the elastic potential energy. From that you can really kind of resemble with an elastic band or elastic systems or a spring. So it's potential energy in a elastic system. So when the spring is stretched, like you see here, you see he's holding the spring, stretching it, haven't released it, haven't turned it into any type of energy yet, but there's potential energy here. Or compressed, he's applying force, alright, and compressing it, and there is potential energy stored, alright, and it has a elastic potential energy, like I said, that can turn into kinetic energy, for instance. And the way to basically calculate it is U, potential energy, is equal to half times K, which is the spring constant, times delta displacement squared. So how far it stretched or how far it went. Then you have the total mechanical energy, which is the sum of potential and kinetic energy of an object related to the first law of thermodynamics, which is energy can neither be created nor destroyed. So E is equal U plus K. U is the potential energy, which is mgh. We already covered that, and K, which is the kinetic energy, half times mass and then volume squared, like I said before. And then the total mechanical energy is constant under the case or under the influence that there is non-conservative forces if are absent. So if non-conservative forces are absent, what are non-conservative forces? They are friction, air resistance, and tension. Work done on an object. So a work that affects an object. So you got the work net, which is basically delta kinetic energy, conservative and non-conservative work. And with the work non-conservative is basically mechanical energy because it's the kinetic energy and potential energy. Work is a scalar, right? Remember that work is scalar, and it's a way of energy transfer. It's one of multiple ways for energy transfer when something exerts force. With work, it's the force applied plus the times the displacement, my bad. And let's say you have an angle, there is F times D and then cos theta. Alright, so the magnitude of the applied force is F and D is for magnitude of displacement. So let's take an example here. Work for gas. So gas expands in a cylinder with pistons pushing up against the piston, exerting a force, that's F, that causes the piston to go up and the volume of the system increases. So if the gas expands, that's work done by the system and work is positive. But if gas compresses, that's work done on the gas and it is negative. Work is negative. Next you have a isobaric process, which is work is equal to pressure times delta volume. If pressure remains constant, volume changes. And then delta pressure, if delta pressure equals 0, then the area under the curve, the pressure minus the V area, is rectangular length of the P. Next you have power. Power is basically the rate at which energy is transferred from one system to another. And then P, power, can be expressed as work. So what is work again? Work can be F times D divided time. But work can also be mgh. Alright? Where did we see mgh before? It's potential energy. Next, you have mechanical advantage. Alright, so mechanical advantage is ratio of magnitudes and forces exerted on an object by simple. So you know how you use a pulley or a ramp to move heavy objects, for instance? That is the mechanical advantage, and it's F out, force out, applied on the simple machine force in. So F out divided force in, and you got, for instance, a lever here, so force in times length for a lever equal force out times L out, etc., etc. Next you have a pulley system. A pulley system is really simple. Let's say you have here a rope that has 100 newtons. Alright, you exert a force of 100 newtons, meaning that the person needs to use 100 newtons to pull the length of the rope as well, okay, to be double displacement. Here, for instance, in example 1, there is only one rope that you need to pull, so you're basically using almost similar force exerted and similar force in order to get lift the for instance box. Alright, but each side you add a rope to, it can make things, there can be less tension when pulling the object. So for instance, let's say you added two ropes, so instead of 100 newtons you're gonna have 50 and 50 of the tension pulling on the a box, for instance. And you also at the same time you have to calculate the length of the rope. So with mechanical advantage, you need to calculate the FO and the FN. Here it's WO divided WN. So you got the load times the load distance and the effort distance. So here, for example, we got 800 newtons times the load distance, okay, and then you got the effort times the effort distance, 800 newtons times 4 meters equal 25% efficiency. So it's not that efficient. So that's it for work and energy for the physics of the MCAT. Thank you so much, and let me know any comments down below. Subscribe, watch, like, and share.